Still not getting in or what?
There's 2 different meetings, you think, or?
It's just one. It's the link to the one that I just sent not too long ago. Earlier today.
Not the one from earlier. Let me say this.
So she might want to check an ASU Jonesboro email.
Do you want me to try it?
Hmm.
Do you want me to try it and see what she's saying?
Mhm.
Okay. You'll have a meeting ID under, if you put 30 years and put invite.
Where was it?
In the actual Zoom meeting you're in.
Okay. That's the meeting ID.
That's meeting ID from the email. I'm curious if it's the same one in the room you're sitting in, or if they did a different one.
It probably did a different one.
She said she did use the one from email.
Yeah, I'm getting the same thing she's got, waiting for the host to start the meeting.
It's strange. Yeah. All right. Sorry about that. All right. Let them know that I'm recording this, so if they want to see this, I mean, I will be posting the link to that on Blackboard for them to watch. That way they won't miss out on anything. Okay. All right. Probably better to do it that way. Okay. All right, let's see. I was here. This was 60% for 15 over 25. All right, now for part C. Here we got 0.012. And let's say we want to convert that to 8%. Now what they did here was multiply the numerator and the denominator by 100 over 100. And they did this, 0.12 times 100, and that's all divided by 100. And then 0.012 times 100 will be 1.2 over 100. It would probably be easy to move the decimal point 2 places to the right to get 1.2. So for something like this, if you're converting a decimal to a percent, what I would suggest, just take the decimal point here, move it 2 places to the right. So that decimal point will be to the 1, between the 1 and the 2. So you'll get 1.2 and then percent. You just add the percent sign. Okay. All right, any questions about parts B and C? All right, part D. This is the same thing here. You could do the same thing with 335.751. Just take that decimal point and move it over 2 places to the right. So it'll be between the 5 and the 1. And this will end up being 33,575.1%. Or simply multiply that decimal by 100, and you'll get this final answer. And then tap on the percent sign. Okay. Okay. Now with the fractions, like in part E, Let's say you want to convert 3/7 to a percent. The way that problem could be done would be probably multiply, I think, by 100 over 100, and then take that 3/7 and multiply by 100. That will be all over 100. And usually we'll treat 100 as 100 over 1. Okay. And then this will be 3 times 100, which is 300 over 7 times 1, which is 7. And that fraction will be over 100. Now they converted that to 300 over 7 with a percent sign. And then they converted 300 over 7 to a mixed number by dividing 7 into 300, which would be 42 with 6 left over. So it'd be 42 6/7%. Okay. All right. Any questions about part E? Yeah, question.
I'm just gonna have to go back and work it over again. I don't understand about half of it.
Okay. Well, let me try to work it up this way.
I'm just trying to understand why you would leave the next number, or I don't think I was ever taught mixed fractions.
Oh, converting this to a mixed number?
Actually, the last 3 steps. 300 over 7 over 100 is not familiar.
Okay.
Why that would end up 300 over 7. Really.
Let me do this. And this is where I'm going to have to bring this forward again.
I'm sorry.
All right. So if I do 3/7, all right, in this case here, what I would do here is, all I'll do this is simply take that 3/7 and multiply it by 100, okay? And 100 is like 100 over 1. That'd be multiplied by 3/7, which will be 3 times 100, or 300, divided by 7 times 1, which is 7. And of course, since I'm changing it to a percent, I just go ahead and add that percent sign to it.
Okay.
And then divide 7 into 300. Okay.
Would the appropriate decimal also be correct there? And
Yeah.
use, you know,
It'd be after the 2. All right, any other questions? Okay. So with these, let's say I want to convert each percent to a decimal, like this one. Say we got 427%, and then I want to okay, let me go back to this right here, and I'm gonna have to yeah. All right, now 427%, and I'm going to change that to a decimal. Now, this is going to be a little bit different. So in this case here, we need to just simply divide by 100. Or another way you can do that is drop this percent sign and move this decimal point 1, 2 places to the left. And you'll end up with 4.27. Okay. So that's how we convert from a percent to a decimal. Basically, drop the percent sign, move the decimal point 2 places to the left. And then for part B, we got 12.317%. All right, for that, we go ahead and drop the percent sign, move this decimal point. Well, here are the decimal points right here. So that means when we move the 2 to the left, it'll be in front of the 1. So in this case here, this will be 0.12317%. And then finally for part C, 0.048. 0.0048%. So again, we drop this percent sign. Now here we're gonna have to move the decimal point 2 places to the left. That also means I need to add a 0 in front of that. Okay. So this will be 0.000048. All right. Any questions about this particular example? Okay. So let's say we want to try these particular problems, like problem number 46 on page 357. Here we're going to express each decimal as a percent. Express each decimal as a percent. All right, so in this case here, what would 4.57 as a percent be? 457%. So basically, we're just moving the decimal point 2 to the right. Okay. And 0.00256. Let's see. Now here's the decimal point. Go 2 to the right, it'll be in front of the 2 this time. So it would be 0.256. Then we add on the percent sign. And 158.6 as a percent. Okay. 2 to the right, it'll be behind the 0. And of course, you have to add a 0 so that you can move it 2 places to the right. So it'll be 15,860%. All right, any questions on this particular problem, number 46? Okay. All right, number 47 on page 357 as well. Now here we got fractions and mixed numbers, and we want to convert that to as a percent. So in this case here, we got 17 over 20. And he'll want to convert that to a percent. So the way I would do this is take that 17 over 20 and multiply by 100 and treat 100 as 100 over 1. Because in the end, I'm gonna add the percent sign as well. Now I think I can do some cross dividing with that 20 and 100, because I know 20 goes into itself one time, 20 goes into 105 times. And then I have 17 times 5, which is 85. Yeah.
Is it also valid to times both by 5 over 5 just to get the 100 on the bottom?
Yeah, you can do that. Okay. All right, any other questions? Okay. Now, part K, we got 12 and 4/5. And we want to convert that to a percent. And of course, I'm gonna multiply by 100. But for that 12 and 4/5, what I would do is convert 12 and 4/5 to a improper fraction. Okay, so here if I do 5 times the 12, the 60 plus 4 is 64 over 5. That's multiplied by 100 over 1. And I know 5 can go into 120 times. And then if I do 64 times 20, that'd be 1280 over 1. That's going to be 1280. And of course, add the percent sign. So this will be 1,280%. All right, questions on part B? Okay, 5 2/3. As a percent. So here I'm going to multiply that by 100. But I'm going to convert 5 2/3 as a mix, as an improper fraction. So I know 5 times 3, that's 15 times plus 2 is 17 over 3 times 100 over 1. So I'm going to have to multiply numerator times numerator and denominator times denominator. And move this over. So in this case here, 17 times 100, that's 1700 divided by 3 times 1, which is 3. And then I have to divide 17 into, by 3.
566.6 repeating.
But you're going to have 2 left over when you do the long division. Okay. Because I think that 0.66 repeating is like 2/3. Okay. And if they want that as a fraction, it would have to be like this: 566 2/3%. Okay. All right, any question about converting a fraction or a mixed number to a percent? Okay. All right. All right, next we'll talk about how to write an equation to solve percent and percent change problems. Okay. Now the equation A is equal to P% times N. We call that the percent equation. Okay. So here the variable expressions are, the letter A is going to be the part or percentage. That's this variable here. And then P%, of course, that's a percent. And N is going to be the base or the whole. All right, now this table, this is also on page 353 in the text. It summarizes the possibilities and provides examples. We mentioned the cases to highlight their similarities and variations of the same equation rather than their differences. Okay, and that's the variations of the unknown. So one of them is finding the part of a number, which is of course A. That would be the unknown. And these are just some examples of that. A is equal to 15% times 4/20ths. And then the next one is A is equal to 15 over 100 times 4/20. And then the last one, A is equal to 0.15 times 4/20ths. Here they're just writing in 3 different ways here. The second task could be represent one number as a percentage of another number. In other words, we're trying to find what percent of the whole would give us that part. And these are just a couple of examples here. 18% is equal to P% of 72. And then of course, P% would be P over 100. So it could be 18 is equal to P over 100 times 72. And then the last one is just finding the base, when a percentage of that number is known. So we're finding the base or the whole. So it could be a percentage of what number would give us that particular part. So like 24 is equal to 162% of what number? N. And these are the 3 different ways of writing it. Okay. Okay, and I think there are various examples of that as well. And I know these are usually found is in elementary math textbooks where they start off by finding the part or the percentage, and then they want you to find what percentage of the whole that would give you that part, and then you want to find out what the whole is when the percentage of that number is given. So we look at this particular problem number 50 on page 357. These are just like that. Where it says in part A, what is 40% of 0.035 M? What is 40% of 0.035 M? So we were to solve this. Here we're trying to find the part, which is going to be our A. And that's going to be equal to, the word is, by the way, represents equals. What's 40% as a decimal? 0.40. And then the word of means you need to multiply, and then 0.035 M. So this is just basically a straight multiplication problem here that we can do here. So 0.40 times 0.035 is how much?
0.14.
What was that point?
0.14.
0.014. And of course, we need the M with that as well. Okay. Questions on that? All right, part B, what percent of 7.25 pounds is 25 pounds? All right, so here we're finding what percent of 7.2 pounds. So here we're looking for the percentage. So your P percent is what we're looking for. And the word of 7.2 pounds is equal to 25 pounds. Okay. So here, I'm gonna write this as P over 100 times 7.2 is equal to 25. So in this case here, because I'm doing a little bit algebra here, so I'm gonna say 7.2 times P over 100 is equal to 25. And then the next step would be to multiply by 100 on both sides. So I have 7.2 P is equal to, what's this, 2,500? And then divide both sides by 7.2. Okay. Now this is what I come up with. And I'm gonna put this over here. P is equal to 347.2%. Okay. All right. Any questions about part B? Okay. And now part C. Let me see if I can erase this top part here. So it said 38 feet is what percent of 242 feet? So you got 38. Is the equal sign. Now we ask what percent, again, that's P over 100. And of is 200, of is multiplication, 242. So in this case here, that P percent, I'm gonna make that P over 100 times 242. That's equal to 38. So if I write this as 242P over 100, that would be equal to 38. And then multiply both sides by 100. The right side is 242P, and the left side is equal to 3,800. And then divide both sides by 242. That would be P is equal to 3,800 divided by 242. And I'm rounding this off as 15.7 Okay. All right, any questions about problem number 50 and how that's done? Okay. All right, in this case here, this is on page 255 as well. There are 250 first graders in the school district. Of this, 48% are boys. How many first graders are boys? Okay. So there are 250 first graders. That's the whole. 48% of them are boys, and we want to know how many first graders are boys. So that's the part. And as A is equal to, of course, P% times N representing the whole. And we got the percent, which is 48%, times N, that's 250. So here we're finding the part in this case. And what's 48% is a decimal? 0.48. And what's 0.48 times 250? Yeah, 120. Now that problem is similar to a problem that we did when we used the bar diagram. But here we're using the percent equation in this case. Okay. And also on this next slide, here they just want to use a percent equation. Here we use a bar diagram for that as well. Has a collection or two of beads. Of those beads, 45% are silver. And she has 126 silver beads. How many beads are in her collection? So in this case, we're looking for the whole. We already know the part and the percent. We just want the whole. Okay, she has 126 silver beads in her collection. So that's the part, that's the A. And that's going to be equal to 45%, which are silver, times N. All right, so what's 45%? It's a decimal. 0.45. So I got 126 is equal to 0.45 times N. So we divide both sides by 0.45. Okay. That'd be what, 280? Okay, so that means in her collection, she has 280 beads. Okay. All right. Any questions about those two problems there? Okay. All right, now we'll look at how to write an equation to solve percent and percent change problems. Okay, now, here we're going to be looking at percent change, and that means percent increase or percent decrease in terms of algebra. Okay, so here the percent change equation in this orange box. Let's say B is compared to A. So here B is going to be P% increase of A if and only if B is equal to A multiplied by P% of A. Okay?
Added to.
Yeah, added to. Yeah, because the percent increase, of course, you have to add. You'll take P% of A, that'd be the amount of the increase, and then you'll add it to the original amount, which is A. to get B. And then for a percent decrease, this time it's the same thing, but it's going to be a minus sign. You'll do the percentage times the original amount. You'll get the amount of the decrease, and then you'll subtract that decrease from the original amount to get B. Okay. Questions on this? Okay. These are just a couple of examples here. The regular price of a calculator is $72. It was on sale for $56. And we want to express that change in price as a percent. And then the B part is the number of students who marched in the annual parade rose by 12.5% to 63 students. How many students marched in the parade last year? Okay. So the first one is representing, it was on sale for $56 from the regular price. That has to be a percent decrease in that problem. Okay. So the sales price is going to be the regular price minus the percent of the regular price. So here we're comparing the sale price of $56 to the regular price of $72. And here's the equation for that. Okay, so it'd be 56 equal to 72 minus P% of 72. So here we're going to do this algebraically. And P% represents P over 100. So it'd be 56 minus, equals 72 minus P over 100 times 72. Okay. Now what they did, they took this expression of P over 100 times 72 and moved this over to the left side to get this. And then they moved the 56 over to where the 72 is by subtracting. Okay. This was minus P over 100 times 72. They just moved that over, made that a positive, P over 100 times 72. 56, they moved that over to the right-hand side, made it a minus. Okay, so here they're using inverse operations here. Now, and then 72 minus 56 would give us 16. So we get P over 100 times 72 equaling the 16. And to solve for P, the 100 is in the denominator, so they multiply by 100. The 72 is being multiplied by P, so we divide by 72. So here they have 16 divided by 72 times 100. And this is to the nearest tenth to 1 decimal place. P is going to be 22.2. So that means, in this case, it'll be 22.2%. Okay, let me go back. Right here?
Right there.
Okay. 72 is being multiplied by P, so we have to divide by 72. Take 16, divide that by 72. That 100 is in the denominator, so we multiply by 100.
They collapsed a couple of steps on this one.
Yeah, I understand, yeah. Because what I would have done here is this. I would have taken this and multiplied the whole, well, I don't think you would, but you could. Get rid of the fraction of 100 by multiplying the whole thing by 100. That probably would have made it a lot easier doing it that way. So let me take it from this step. Let's see, 56 is equal to 72 minus P over 100 times 72. And I would have did this. And then multiply the whole thing by 100 on this side. And all of this would have been multiplied by 100. So this would have been 5,600. And this would be 100 times 72. That's 7,200 minus 72p over 100 times 100. Those are hundreds will divide out. And I give you this. And then subtract 7,200 on both sides. This would be, I think, negative 1,600 is equal to negative 72p. Then divide both sides by negative 72. Textbook does it a different way, does it the way they want to. But
When they skip steps, it's not useful.
yeah, it's not. Okay. Questions on this?
Write down what you wrote there.
Okay. Is
I like that way a lot better.
Use.
no wonder so many people want me for math.
Oh, yeah, for sure.
Okay.
You do have a glare right over the equation.
Yeah. Because of these lights.
You probably took the board forward.
Hmm.
You probably took the board forward.
Okay. All right. Okay, now we can move on. Well, there we go. So here the change in prices, and they're using the negative sign, negative 22.2%. Or you can say, in this case, 22.2% decrease. All right, now this is part B. Where you got the number of students who marched this year is equal to the number of students who marched last year plus a percentage of the number of students who marched last year. Okay. So in this case here, we're letting N represent the number of people who marched in the parade last year. Okay, and that would be the formula that you'll have to set that problem up as. The 63, that's the number of students that marched this year. And N is the number that marched last year. That's going to be N plus 12.5% times the number that marched last year. So let me do this. 63 is equal to N plus 12.5% times N. Now, let's convert 12.5% to a decimal. What would that be? 0.125. So I'm going to have 63 is equal to N plus 0.125 N. Now, if you notice that these are like terms here. So this N is like a 1 N plus another 0.125 N. So if I add $1 to like 12.5 cents, this will be 1.125 yen. 1.125 yen. And then I'm gonna divide both sides by 1.125. So this is what, 56?
And a problem like this, if it came out from decimal, would be kind of a key that it was the wrong answer, yes.
Yeah, because
You
it,
can't have half a student.
yeah, because there's no way you can have a fractional or decimal part of a student. And as you can see, they're pretty much did the same way. So that means 56 students marched in the parade last year. Okay. Any questions on example 53? Okay.
You want, I mean, you can go on, I can get it from her.
Okay. All right. This is problem number 34 on page 357. There are 42 boys in the first grade. There are 20% more boys than girls. How many girls are there?
So, boys would be A.
Okay. Well, they want you to solve this using A, and we're looking at two ways, the bar diagram and using a percent equation. All right, so if we were to do a bar diagram for this, let's see here. There are 42 boys in the first grade. Okay. Let's say this is 100%, because this shows that there are 20 more boys than girls. So from here to here, there is an increase of 20%. So that's 120%. And then the question is, how many girls are there? Now let G be the number of girls. So with this one, we can set this up as a proportion. Okay. So here's a proportion. G over 100, girls represent 100%. G over 100, that's equal to 42, the number of boys, over 120. Okay. So the number of girls represent 100%, then 20% more than that will have to be 120%, which represents the number of boys. So here's our proportion that we can solve here. And if I cross multiply, I'm gonna have 120G, that's equal to 100 times 42, which is 4,200. So 120G is equal to 4,200. Divide both sides by 120. G will be equal to how much? 35? So that means there are 35 girls. Okay. That's using a bar diagram. The The B part is using a percent change equation. Okay. So if I was to use a percent change equation, it would be this. There are 42 boys total, and that's going to be equal to, and here I want to find the number of girls. So let's G be the number of girls. And of course, it's an increase, so we have to use the percent sign. We're given 20% times G. And of course, 20% as a decimal will be 0.2. And this G is like 1G. So if I combine these two like terms here, 1G plus 0.2G will be 1.2G. Then divide both sides by 1.2. That means G is equal to 35. So using a percent change equation, this will be 35 girls. All right. Any questions about problem number 34? Increase. All right. A bag of green peas in the pod is sold for $2 after a discount of 20%. What is the regular price? Okay. So in this case here, that's where we use a percent change equation. And that's B is equal to A. And of course, it's a discount, so that means it's going to be a percent decrease. So it'll be A minus P percent times A. So in this case here, after a 20% discount, it was sold for $2. So that should be, this $2 is equal to, now A is what we're trying to find, minus P, which is 0.20, well, actually 20%, but we know what's that is as a decimal, times A. This will be 0.2 times A. So now I get A minus, okay, what did I just do wrong? Yeah. There we go. Okay. So here, this will be A minus 0.2A, which is equal to 2. This is like 1A. So if I subtract $1 minus 20 cents, this will be 0.8. So it'll be 2 is equal to 0.8A. Divide both sides by 0.8. Two divided by 0.8. So 2.5. Okay, or $2.50, yeah. Since we're dealing with money amounts. Okay. So the regular price is $2.50. Any questions on problem number 62? All right. Let's say we had this 7% of a number is 18 more than 3% of the number. And here I want to find that number. let's see, 7% of a number, and I'm letting n be the number, and of represents multiplication, is the equal sign, 18 more than, and more than means addition, 3% of, which is multiplication, a number. Okay. Now we want to find the number. 0.7% as a decimal will be 0.07 times n. That's equal to 18 plus 3% of a number will be 0.03 times n. So now, what I'm going to do here is get all the n's on one side of the equation. I'm going to move that 0.03 n where that 0.07 n is at by subtracting 0.03 n. Let's see, 7 minus 3 will be 4, so that'll be 0.04 n equals to 18. Then divide both sides by 0.04. Be 450. So the number we're looking for is 450. Okay, questions on problem 58. Okay, and this is the last slide here. This deals with how we can use fractions, decimals, ratios, and percents to make comparisons of the same quantity. Like in this case here, 32 nickels and 20 pennies. These are just all the ways that we can compare those two. 8 nickels for every 5 pennies, 1.6 times as many nickels as pennies, 3/5 more nickels than pennies, or 60% more nickels than pennies. Okay, and the same thing here. Okay. Questions about section 6.3. Okay, so that wraps up that particular section. And I'll go ahead and open up that homework for section 6.3 for you. And that's going to wrap it up for today. All right, Monday we'll start chapter 7 dealing with algebra and functions. I did open up quiz number 1 on in WebAssign for you to complete. And I also open up that homework as well. And if you haven't gotten your WebAssign, try to get that as quickly as you can. That way you won't fall behind. Okay. All right.
From Mark Taylor here, since you tried so very hard to get into this room.
Okay. 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 Well, I'll probably have you just do the Zoom. Just send this. I'll probably have you just do what you did Monday. Just let her in.
And I photographed and sent them my notes afterwards, and they seem to be okay with that.
Okay, good.
Who else was in? Kayla and Sylvia. For class, for second. What's the class key?
Okay, let me.
Emily Martinez.